Welcome back, friends. Now that you have understood the operating parameters and the operating features of a public transportation system, in this lecture what we are going to tell you in detail is how do you measure the bus and the rail transit capacity. So, this is the I have two parts of this lecture. In the second part of the lecture, I will be looking into different types of solved examples. In this part, we will introduce you to the concepts of bus transit capacity and we will look at how capacity and speed estimation process is carried out. Similarly, we will be looking at rail transit capacity concepts and look at how rail transit capacity estimation process is carried out. So, when we are talking about the capacity of a bus transit service system, we are looking at travel time, capacity based on travel time and capacity based on travel time or delay associated with bus facility. So, travel time is something that we are looking at, travel time with bus stops or travel times with bus facilities. See, travel time, so this is something that you have to start understanding that the capacity of a public transportation system can be measured using time. So, capacity usually we think is the number of people that you can fit in your bus service, but usually it is the number of people that crosses a certain point in a given amount of time, right. Remember the definition of speed and travel times, right. So, travel time and reliability affects the quality of service. If you have unreliable travel times or if you have very high travel times, then people will not ride your public transportation system. Speed and reliability affects the time required for a bus to make a round trip as well. So, from a user's point of view and an operator's point of view, you see they all impact the public transportation system. They also affects the number of buses needed to be served on that road on that route given a specific headway that it has to maintain, right. If the travel time taken is too much between two stops, then there has to be more number of buses that have to be in operation, and that increases the operation cost as well. So, capacity of bus transit service can be looked at from the point of view of travel time and travel time at which locations, the travel time at bus stops or travel time with a bus facility. So, let us look at capacity of a bus transit service and look at what are delays associated with the bus stops. So, look at it from the point of view of bus stops and how you can minimize those delays to maximize the capacity. So, usually at the bus stops, buses decelerate, the time spent slowing down to serve the stop. There may be bus stop failure. So, waiting for other buses to clear the stop, right. Maybe there is no space for this incoming bus to stop because there are other buses that are already at the bus stop. Boarding lost time, waiting for passengers to reach the bus. If you are not, if you do not have a bus bay, then you are waiting on the pavement, and there is some time lag that happens for the passengers to come out of the bus stop, come onto the pavement and then access the bus, that is boarding lost time. And then passenger service time, which is the dwell time, which you already know about, right. So, deceleration is the bus is coming and so it has to lower its speed. Bus stop failure, it cannot get in there because there are parked vehicles and two buses are already being served. So, it cannot get in there. Boarding lost time, now there are lots of people already boarding another bus or they cannot reach this bus in time, and then the actual dwell time which are needed for the passengers to board and alight the bus. So, all of this contributes to the delay associated at bus stops, and these delays essentially then reduces the capacity of the bus transit system. The other three situations are delays caused due to traffic signals, right, waiting at the traffic signal to turn green or something or the other. Even if you may not have free left turn in our situation, right, the buses may not be able to turn free left, even though there is a left turn lane also maybe but the signal said no turn on left, no turn on red. Similarly, there may be re-entry delay. So, if you already have entered into the bus stop, but now there are other vehicles that are not allowing you to get back out. So, there may be re-entry delay, and then there is some delay because of accelerating back from your stop to the speed that you want to pick up. So, all of these things cause delays to the bus service, or cause delays to the one particular bus, which then can be accumulated into the entire service, and then that reduces the capacity of the bus system as a whole. Stop spacing. Now, if we start looking at delays associated with the bus facilities. So, what are the different types of bus facilities? Stops may be one type of facility, exposure to other traffic, on a mixed traffic facility. If you are running your buses on a mixed traffic situation, add grade, then you are exposed to other kind of traffic which causes delay. We have told you if the spacing on one hand, if it is close to each other, you may maximize your person capacity, but then the bus has to stop every 20 meters, 30 meters. So, that reduces the speed, and that increases the delay, and then reduces the capacity of the system as well. Facility design, maybe the streets are do not provide enough turning radius at certain junctions. So, the speeds of the buses have to be really slowed down, or they may not be able to enter that route or that lane, and hence has to go around, and that increases the travel time or reduces the capacity again. And then there may be bus operation factors that comes into play, whereas more and more due to congestion situations, there will be platooning, there 2 or 3 buses are bunched together, and that causes again a reduction in the capacity. So, what are the places where capacity is calculated when it comes to a bus transit system? It can be calculated at the loading areas of the bus berths, right. These are the loading areas usually. So, you can calculate the capacity of loading areas, that is the curbside space where single bus can load or unload passengers. You can measure the capacity of the bus stop together with the loading areas, right. So, if there are 2 loading areas in a bus stop, then the entire bus stop consists, you can measure the capacity of the entire bus stop as well, and then lastly you can of course measure the capacity of the bus facilities, which consists of 1 or more consecutive bus stops. So, this is the entire facility for which also you can conduct or you can measure or estimate the capacity of your public transportation system, right. So, you can do it at a very micro level at the loading areas, you can do it at a meso level at the stop, or you can do it at a macro level at the facility. You can measure the capacity at 3 different levels. So, by knowing the loading area, by loading that is the lowest denominator, if you will, where you can calculate the capacity, you can then aggregate it up to the bus stop, to the facility, and then you can convert it into person capacity. So, the person capacity is nothing but the bus facility capacity times the bus passenger capacity times a peak hour factor. There is always a peak hour factor, because remember in the previous lecture we told you that the bus operations vary based on different hours of the day. There may be peak hours, and within peak hours there may be peak periods as well. So, there is always a peak hour factor that is factored in order to understand what is the person capacity or the number of people per hour that your public transport service can move, right. So, there are simple formulas for understanding what are how to measure or how to calculate load area capacity. It is the seconds in an hour available for bus movement divided by seconds that a designed bus occupies the stop. These are in the units, both are in the seconds unit. So, it is a unitless a measure. So, what you have to do is you have to know how many seconds in an hour is it available for bus movement. That means there are 3600 seconds per hour, multiply that by the percentage of time traffic control allows the bus to enter or leave that stop. So, you have to do some manual calculations, you have to understand, you have to be at a bus stop or bus station and figure out how much time, what percentage of time does traffic control meaning the traffic environment around that bus stop allows the bus to enter or leave that stop, right. So, multiply that by 3600 and divided by the seconds that a designed bus actually occupies that stop. So, the time that the bus occupies the stop will include a portion of the dwell time, right. The time waiting for a gap in the traffic for to leave the loading area. So, the bus has to leave the loading area. So, portion of that time is also needed. Clearance time while a bus travels its own length while leaving. So, when the bus is leaving out of a bus bay, its entire length, it has to cross the entire length. So, that is the clearance time needed, and allowance for particularly long dwells. Sometimes the dwell times are longer if there are large number of passengers loading from that loading, embarking or disembarking or boarding from that loading area or that stop, right. So, that is a simple enough ratio to find out. Similarly, bus stop capacity now can be calculated by multiplying the loading area capacity that you have already figured out by the number of effective loading areas at that stop, right. There may be 2 loading areas, but one may not be available because of encroachment or whatever it is, some other reason, parking vehicles parked on there. So, or even the existing bus may not have docked at may not have stopped at the right position. So, it may have taken up both the spaces and the other bus is not unable to come inside this loading area. So, there may be, but so that is why you have to calculate the number of effective loading areas and not just the number of loading areas at that stop, and the adjustment factor for traffic blockage, which is a function of the bus stop location. If it is blocked by parked vehicles, for example, for right turning or left turning volumes, if there is conflicting pedestrian volumes. So, there are different adjustment factors. These are standard factors that have already been developed in many based on many operating conditions. You may adopt that for your situation, or you may develop your own factors based on your local traffic conditions as well. Similarly, then for calculating and estimating the bus transit capacity, you have to know what type of facility your bus is running on. Is it a one lane, one direction unidirectional facility where the bus cannot overtake any other vehicle. So, if there is some vehicle in front of it, it cannot overtake, that limits the capacity of the bus of your system. If there are 2 or more lanes in the traffic direction, then your bus may be able to overtake and access the bus stop, or do a turning movement or whatever that allows it to move faster in the traffic stream, or type 3 where the buses have full use of the adjacent lane, including busways. So, you have dedicated right of way for the buses to move. So, that type of system also is the best for when it comes to having good capacity for the buses. The second thing to understand is how to calculate bus transit speed. So, you have to assume some sort of first you have to assume some sort of a unimpeded bus running time rate, right. So, what you usually do is you look at the posted speed limit and you say that the bus, if it was unimpeded, if there was no traffic on the road, this is the rate, this is the number of buses that could pass through this segment in a given period of time, right. Based on the speed limit, you can calculate the bus speed, that you can assume that this might be the rate of buses that is going through that segment. Then you start to account for different types of losses. Now, then you try additional running losses for traffic signals and delays. Now, you say add those losses, adjust for bus interference and skip stop operation when there is bus bunching happening, that reduces the bus speed. So, all you take into that into account. After all that, then you convert the adjusted running time rate to a speed. Then you convert this, use all these lost times, and then finally convert them into a speed. So, let us look at how unimpeded running, what do we mean by unimpeded running time rate accounts for travel time at a facility's posted speed plus dwell time and acceleration deceleration delay, right. So, whatever the posted speed is plus your dwell time and acceleration deceleration delay will give you the unimpeded time rate. When stops are too closely spaced, need to make sure that the bus can accelerate to the posted speed before slowing again. If it can't, then you set the running speed at a lower than the sports. If the two stops are too close to each other, then there might be a situation that the bus may be able to reach 60 kilometers per hour top speed, but since it is the next stop is only 500 meters away, it cannot get back, it cannot accelerate up to maximum speed, it can only accelerate up to maybe 20 kilometers per hour, and then it has to start decelerating again. So, then the speed that it reaches is never its maximum speed. So, you have to then let it run at a lower speed than the posted speed limit as well. So, these are standard numbers that are given for average dwell times and how many stops per mile if you have. So, if for example, you have 6 stops per mile and your average dwell time is 10 seconds. So, this is what you are going to have as your unimpeded running time rate. Additional running losses also, running losses because of right turn lanes, because of mixed traffic flow. So, there are different for different types of land uses. For example, on arterial roads outside the CBD and in the central business district, you have different such figures that have been calculated mostly in the western countries, but you get the idea of how to measure this and what may cause the delay, and you can carry out similar running losses or running time losses for your city public transportation network as well. Bus interference, as I was saying, if there are when the number of buses when the number of buses scheduled exceeds half of the facility's maximum capacity. So, if it exceeds half of the facility's maximum capacity, buses will begin to interfere with each other. So, bus failure, passing, leapfrogging activity. So, when you see two buses trying to race against each other, right, that is when you know that your bus transport network is not functioning well, because they should not be competing against each other, they should be helping or working in parallel to each other, so that the efficiency is increased. So, what happens to the bus speed? So, you see the bus speed, average bus speed starts going down when the bus lane V by C ratio starts going up, right. There are more number of buses than the capacity that it can hold in that facility. So, as that keeps on increasing, your bus speeds goes on reducing. So, you never have too much bus bunching going on in your system. So, this is a generic steps that are usually calculated, usually done in order to estimate the bus transit capacity. You design all you get all the background data, socioeconomic data, demographic data from of your city. You set a design bus stop failure rate, right. And then against that design rate, you start determining the dwell time, determine the loading area capacity, and then determine the bus stop capacity. We have understood that the loading area is the lowest denominator, then it is the bus stop capacity, and then it is the bus facility capacity. So, here we are only stopping at the bus stop capacity level. So, next if we start looking at the rail transit services, their capacity calculations are also, the principles are very similar to bus transit capacity, but there are few other factors that come into play when you are trying to calculate rail transit capacity. Like you say here, like we look at here, a rail transit capacity depends upon, there are two different things that we talk about. It is either the line capacity or again the person capacity. So, you know how to measure, we have person capacity in terms of when we talked about bus transportation systems, but we never talked about line capacity in bus transport systems. So, let us look at what is line capacity here. Line capacity is the number of trains that can pass a given location during a given time period at a specified level of reliability. So, you see that the definitions are also very much similar. There we had bus capacity or vehicle capacity. Here we have line capacity. Person capacity is similar to what we have in the bus transport arena as well. Again, here also we have reliability. So, maximum capacity is only achievable when service is 100% reliable, passenger demand never varies. So, this was the situation for bus transport as well. So, when you talk about bus and rail transport, the basics are very similar. When it comes to measuring the capacity. There are few other elements that we look at in rail which are different from bus, and that will give you an idea of it. So, again, dwell time is very similar. Signal system plays a important role. Even for bus transport, the signaling on the urban roads plays an important role, but for rails they have dedicated signals which also play a role in understanding the capacity of the rail transport system. Operating margin is something that plays, and we will see what that is. Headway, like we have looked at even in the bus situation. Junctions here play a role. Turnbacks is something that buses don't have, so we will take a look at that, and also power supply, which again buses don't have to be plugged in unless they are now new electric buses that are coming in play. So, they will be affected by power supply. So, dwell time, we already know it is calculated the amount of time that a transit vehicle waits at a stop and to allow the passengers to board or disembark. Train signaling system, so this determines the minimum safe spacing between trains. So, better accuracy in a train's position results in a higher train throughput, right. Now, train signaling systems are very important because not only from the capacity point of view, but also from the safety point of view. So, these possible elements, these kind of signaling systems, when they are trying to improve the capacity, they will however always keep in mind that the signals will not interfere with the safety of the system in order to increase capacity. So, capacity will always be secondary and safety will always be primary when it comes to train signaling systems. Although you would want to have signals give a lot of minimum red time and more green time and green more frequently, so that more trains can come, but that may impede the safety of the train systems, right. So, that is something to keep in mind when you are trying to design your train services or train public transport services in your urban area. I am not getting into intercity rail yet. This is just take this into consideration for metro rail services, for example, or maybe light rail services that may be available in your city. Operating margin, now this is something that rail systems always worry about. So, this is an allowance for longer than average dwell times. So, usually what happens is sometimes the trains wait at a station for a longer period of time because there are multiple cars in a train system, and to load and unload passengers it may take longer than average dwell times. So, if a train dwells more than the average dwell time plus the operating margin, and the following train is scheduled with the minimum headway, then the next train will be delayed, right. So, there is always this operating margin that is given to all the train services, to the each of the train lines, that you have this buffer. So, this is the operating margin can be looked at from the point of view of a buffer, that you have this buffer time, that if you want to wait in a station for 2 more seconds you can do so. However, you have to leave within the next half a second, because otherwise if you don't, if you cross that threshold, if you cross that buffer margin, then the train that is following you might be delayed, right. So, operating margin is sometimes always kept in mind very carefully when you are actually calculating how much dwell time each train should get at a station. Minimum non-interference headway is equal to the critical station average dwell time plus the operating margin plus the safe train separating time. Again, there is always a a minimum headway that has to be kept. In case of bus transit, we notice that we always try to minimize the headway as much as possible, because it is easier in the case of buses to control the headway, but when you are on rails and when you are on tracks, you have to maintain a minimum headway. And you should not tinker with that minimum headway, because then because the trains are usually at higher speeds, then it becomes very difficult for you to decelerate at the given time, and it may cause a collision with the train ahead of you. So, always maintain a minimum headway, keep that in mind even when you are designing for maximum capacity, right. Capacity, remember again, capacity should not come as a come in the way of lower safety. Higher capacity should never come in the way of lowering safety. An important thing in case of trains are these junctions, right. These are the picture, of course, is of an intercity rail system, but even in metro rails and all, you would have seen that there are certain junction areas where the trains have to turn around, or there are multiple train lines, metro lines that combine at one rail station. So, that becomes a junction. So, what happens is that the tracks cross at grade. So, when the track starts crossing at grade, that is when at these junctions there is some delay that is incurred to the movement of the trains. Then the train movements through conflict points must be controlled, and the train crossing movement must be coordinated with train movements in both directions of the line being joined. So, always 150 to 180 second headways, if possible, are given at grade separated junctions. So, again this adds to your delay and has to be taken into consideration when you are calculating your headways as well as your capacities. Then there may be similarly there may be line merges at junctions where train on one line arrives late. So, it's to fill its slot, delaying the next train on the so if but usually these have right of ways, right. So, right of ways does two things. Right of ways allows you no interference with the other traffic. So, you can provide reliable travel times, but if anything goes wrong, you have your dedicated right of way. So, you cannot fix it very quickly. So, smaller delays adds up to making a larger delay as well. So, right of ways, a dedicated right of way always is something that has both advantages and disadvantages. Turnbacks, these are usually provided for at railway stations, so that typically that can handle two trains at once in high capacity stations. So, you see if the first train arrives and goes on this type of this side of the station platform, the second train arriving can go at the other side, and that is why you provide this kind of a railway crossing or which are called turnbacks. And then if this station if this the train which came here had to go back, then it can again depart from that station independent of this train which is now sitting at this platform, and another new train can come in and use these platforms. So, these turnbacks are a very important feature of any rail transit systems, and they help improve the capacity of the train train transit systems. And of course, then you have your power constraints, electrical traction power systems, locomotive halt commuter rail. So, this is more the number of cars per train limited by the locomotive horsepower. This is when it comes to long distance or regional railway, whereas electric traction power systems are more of your metro rails. The number of trains in a section of the track may be limited by the capability of the substation serving that section that supplies the power, right. So, you have to take into account the actual substation capacity that you are utilizing for your trains. So, when people say that why don't you add another metro rail another car to the metro rail that arrives during peak hours. So, usually we do not realize that another car will car or bogie, for example, will need additional power, and if we are already running at maximum power from the substation from which we are drawing power, then we may not be able to add another car or a bogie to the rail. So, what are the person capacity factors for rail transit? Again, if you want to calculate person capacity, the train length, of course, the number of bogies that you have, number of cars that you have in the train, the train car passenger capacity, each car how many seatings are there, you are allowed a few standing passengers to measure the capacity. Then you will always have a peak hour factor, and of course, the line capacity, whether you have a double line, a single line, and even with a single line, how much capacity can you, how much headway can you have between two consecutive trains. Right, train length, we understand supply of cars, station lengths, city block lengths. Right, number of cars will depend, supply of cars will depend upon how big your city blocks are. If your city blocks are too close to each other, then passengers may get on and off very frequently, and you may not need too many cars in your metro rail. Whereas if your city blocks are longer, then people may not get on and off, and you may need more and more cars or more and more sitting capacity in your train. Car passenger capacity depends on seating configuration and agency loading standards. So, you cannot overload a car arbitrarily. There are some loading standards that you have to follow, and you have to. So, what happens when the car is sometimes you will see that when the metro rails are at capacity, they would not stop at a station. They would just come and the doors would not open, and the train would go away, because that particular car is at capacity. So, you cannot load any more. Peak hour factors, obviously, for light rail, heavy rail, these are the factors that are already in use. We have looked at a line capacity, and then this is something of a generalized rail capacity measurement steps. You always maintain a minimum train control separation between two headway calculations for safety. Junctions at the headway, you have to limit them, determining the controlling headway again, determining the terminal layover time, and then throughput to understand what is the person capacity of a railway. So, what we will do in the next lecture is to give you couple of 2 or 3 examples of solved problems, which will allow you to understand how these capacities and speeds of these public transportation systems can be measured, can be calculated, and that will help you in designing your public transportation system for your city. So, in conclusion, in today's lecture, we looked at the factors that influence the bus transit capacity, and also looked at the methods for estimating the bus transit capacity. Similarly, we looked at the rail transit capacity factors, and also how to estimate the rail transit capacity. Thank you once again for your attention.